Okay, so today you're working with monomials and properties of exponents. Monomials are variables and numbers which are multiplied or divided. There's no adding and subtracting, so you're looking for a single term, just one bunch of stuff, one clump, a single term of stuff that's multiplied or divided. Because dividing is really the same thing as multiplying, divided. You can't have any weird square roots of variables or things like that. You can have square roots of numbers, but no square roots of variables, nothing bizarre going on, just variables which are multiplied and divided, and then maybe some coefficients. So it would be okay to have x squared over y cubed. It would be okay to put a pi in front of it or a 3 in front of it, or you could even have, say, a square root of 11 on the bottom. All that's fine, but you cannot have a square root of x. You cannot have, I'm trying to think what else would happen. We haven't talked about these yet, but you can't have an x to the 1/4 or any kind of weird fraction exponent, none of that stuff. That is not what we're talking about. Where you're most likely to go wrong is if you see something like x squared plus y cubed. That's not a monomial either because it's got this adding thing right here, so we're not going to do that either. Really what we're talking about today is how do you simplify a monomial? How do you write it in its cleanest form? So these are the things that you can't have. No powers of powers, each base appears exactly once, all fractions are in simplified form, and there are no negative exponents. We'll come back to these rules, or you should write them down and then make sure you understand how to get rid of them all. You should also, and then we'll come back and look, make sure you also understand these words, what it takes to simplify something, that's following these 4 rules, what a monomial is. The base is the variable, so in the expression down here, x would be the base, y would be a base. The constants are these things in here. It's okay to have weird-looking constants. You can't have weird-looking variables in the base of your exponent. Here are all of the rules to simplify monomials. I'm not a big fan of memorizing the rules. I don't think it really helps. I'd rather have you have some examples in mind that help you remember what to do and then apply those. But these are the things that you need to do. Copy them down somewhere if you're a rule memorizer. Know that they're here if you need them again. But really, what I'd rather have you do is memorize, is how be able to come up with a couple of examples that you can use as a model. For example, or one of the ones that I use a lot is x squared times x to the 3rd. I can even write that out. That's x times x. What does that equal? X to the 5th. Oh, if I'm in a situation of something that looks like this, where this kind of a problem, I know that then I'm going to be able to write that as x to the 5th because I see that I've got 5 here. That's really this product of powers here. Same thing with the quotient of powers. I would really want to write out x to the 5th. Actually, let me do that in red. I'd really want to write out x to the 5th divided by, say, x squared equals x over x, and then I can cancel out 2 of them and then say, oh, what I have left is x to the 3rd. That will help, I think, more than just memorizing a particular rule, especially when you get down to this one, the power of a power one. The similar example for that would be x cubed squared, which means 2 sets of x to the 3rd. So I have x to the 3rd times x to the 3rd, and then you should be able to see that's x to the 6th. So you would know in this case you'd want to add, in this case you'd want to multiply, but you wouldn't have had to memorize the rule. You could just come up with this. The only other one I really want to talk about is this one, the 0 power one. That's a definition. We want it to be that. The reason we want it to be that is if we have, say, x to the 10th over x to the 10th, we know that those all cancel out and we get 1. We also know that if we apply the quotient of powers rule, x to the 10th divided by x to the 10th is x to the 10 minus 10, which is x to the 0, and we want those to be the same thing, so we define x to the 0 to be 1. Okay, a couple places where you might go wrong. Be careful with negative numbers. A negative in an exponent means move stuff somewhere. So if you have x to the negative 3 over y to the negative 2, that means that with the negative exponent on the x, you want to move it down here. So now your x to the 3rd should be here. Same thing with the x to the negative 2. That's in the wrong spot. It has a negative exponent. That means move it up here. A negative in the exponent is a direction. It's not a value. It's an instruction, or it tells you what to do. It tells you to move stuff. Don't think of it as a negative value. If you have negative 3 here, that's a value. If you have negative 3x to the 4th power, that really means you're going to take negative 3, let's see a better way to say that. You're going to take negative 3x times negative 3x times negative 3x times negative 3x is going to give you x to the 4th, and then negative 3 times negative 3 times negative 3 times negative 3 is a positive 81. In that case, the negative sign is a value. You also need to be careful with where things are. If you have negative 3x to the 4th, that's not the same thing as the example in black. That means negative 3 and then x times x times x times x, which is negative 3x to the 4th. That's not the same thing as putting the exponent outside the parentheses where it applies to everything in the parentheses. This 4 only applies to the thing it's next to. So pay attention to those things. Okay, here's some examples to try. The answers are here. Make sure you understand where those things came from. In particular, I know a lot of people on number 22 make that be 8x to the 4th, but if you think about multiplying it out, if you're not trying to memorize the rules, you should realize that that's 2x times 2x times 2x times 2x, which is an x to the 4th, and then 2 times 2 times 2 times 2 is 16, so not 8. Similarly with this one, number 20, think about how to multiply that out. That really means 4 sets of n to the 4th. So that's n to the 4th times n to the 4th times n to the 4th times n to the 4th, which gives you n to the 16th. We've got 4, 4, 4, 4. 4 sets of 4, that's 16 times that n is multiplied by itself. The negative 2 exponent here means that you're going to move the entire thing down below. So you're going to get a to the 3rd, b to the 3rd, and then that ab moves down, and there are 2 of them down there. So take a moment to make sure you get those answers. Write down any questions you have on those. And then there's some more examples here for you to try. Answers here worked out for you. So try those. I'll move this up and down so that you can see there are lots of there are a couple other examples at the top you can try, and then the answers for the ones that we had. And then you should have this worksheet. You can try these. The answers worked out, but you can also see the answers online. I don't think they're worked out there either. Well, no, these are sort of worked out. Anyway, you can try these and then come prepared in class to ask any questions you have for these.